My name is Zach, and this is Science Explosion at Hudson Public Library in Hudson, Iowa. All right, so today we're going to be talking about the science of sunscreen. All right, so what is sunscreen? What does it do? And why do people use it? So these are good questions, and I think it's really important whenever there is something that is around us to question why we do it. And so, what is the reason behind all this? All right, so the sun, as you can see it in the sky, remember, don't look directly at it. It's going to have light rays that are going down at the Earth and in other directions too. And so that is going to be what's called radiation. And that is the way that the light goes. Now, I'm not going to make this too complicated because light goes in waves and are also particles. That's a little complicated, but basically what you need to know is that the light is traveling from the sun and then it's coming here to Earth. And then it will hit all sorts of things, and one of those things is going to be you. So you might have heard the term solar radiation before. So that is the big reason why people use sunscreen to begin with. So I've got a bottle of sunscreen right here, and this is actually specifically for using on your face. It's also a lotion sunscreen. And so sunscreen is going to be made, or sorry, not sunscreen, the sun, the waves itself. Let's talk about those first. So they're going to be made up of UV rays and among other types of things. So it's going to help you to know a little bit about what light kind of is. So light is going to be traveling down, and from whatever source it is, in this case it's the sun, light is going to be coming in what they call a spectrum of colors. And the easiest way to think about this is normally you're not seeing all the light in the room, it's just helping you to see other things. But if there is a rainstorm, and then after that rainstorm, there are little particles of water in the air, and that reflects the light in different ways, and it's actually going to break it up into different colors. You know what that is? All right, if you haven't figured that out, I'm talking about rainbows. So rainbows is, light is basically white, and when you split up white, it turns into all the different colors. And so when we think about a rainbow, so think about the Roy G. Biv of that: red, orange, yellow, green, blue, indigo, and violet. So it's going from here to here. So you heard the last one I said is violet. So when I say ultraviolet, so ultra means beyond. So I know for any of the My Hero Academia fans out there, you've probably heard their saying of plus ultra. So ultra means go beyond. So ultraviolet, so beyond violet. So it basically means the colors that are past that range, and we can't actually see those colors. So things that are ultraviolet are things that are past our ability of our human eyes to be able to see. Now, that doesn't mean that they're not there though. So one, we are not the only things with eyes, and some animals actually can see in the ultraviolet. Things like shrimp actually can see actually higher frequency and lower frequency than we can. We do definitely not have the best eyes in the animal kingdom. That is for sure. We don't have the worst by far either, but we don't have the best. So there are some things that can see that. And we can also make goggles and different things that can help us to see those. And you can look up videos of them online, and they used to be a lot harder to get, but you can actually get your own ultraviolet UV type goggles. All right, so that's what's important to know. Think about a rainbow. It's this spectrum or this range of colors, and the ultraviolets are past that. So they just like sound waves, if you've ever thought about how sound waves work, light waves work in a really similar way. They're moving like this, and the ultraviolet ones are going to have a lot more energy in them. So once you get to there, that's why people start talking about the radiation from that. So all right, those are going to be broken down into different ways. But also, real quick, I want to talk to you about colors because this I find really interesting. So let's just do the paper that I've got here. What color is this? It's not a trick question. So hopefully you can see it decently well. This is orange. All right, so I told you that the light from the sun is white and that it then is all of the colors hitting this. So when it hits this, and this is orange, what does that actually mean? So that's a really interesting question. So basically, colors can either get absorbed or reflected off of a surface. So basically, all the colors from the light, the spectrum of colors, are going to hit this thing and they'll either get absorbed or reflected. And basically, what happens is that those colors get reflected off, and then the color that makes this orange, that is going to get absorbed into this. So what we think of as colors is actually the different way that light reflects off of things. And if you want to experience how this can change how much light is in the room with you. So you might notice that some things look different depending on how much light is in the room. So let's see. I've got a piece of paper here and I am in a high light room. There's a lot of light coming in the room right now. I've got the lights on the ceiling and there's light coming in from the windows. And so if you notice the black text on the page, you might think black, that's a dark color. But actually, if I were to turn off the lights in this room, the light that's reflecting off of the black text on this paper, because it's so light in the room, there is more light reflecting off of that than if I turn off the lights on the white part of this paper if the white is off. So it really makes a difference. And if you want to learn a little bit more about this, I would suggest that you go online or get one of the books that we've got at the library here about optical illusions. There's a lot of shadow illusions that will play tricks on your mind having to do with how our brains just automatically interpret light. And I've got one, and I know that this is going to be a little bit dated at this point, but there is one that was very, very, very famous on the internet. I think that was a couple years ago at this point, but that was the dress. What was it, blue or black or white and gold? So the reason people argued about that so much is because it looked different to different people's brain interpretations of what color that was, because the lighting was low in that room and your brain had to struggle to figure out what it was. Okay, so anyway, that's just a little bit basic about colors. So you can't see colors without light. So if you're in a pitch dark room, you're not going to be able to tell what color anything is. You need light to be able to do that. All right, so ultraviolet, that's past the violet. So when you're talking about the radiation coming from the sun, the reason people worry about that is because it can actually damage your skin. So there's UVA, UVB, and UVC lights. So UVA is the kind that is the most common that gets to the earth. So a lot of UV light actually gets bounced off of our atmosphere and doesn't even get in here. UVB, so it's like 95% is UVA. UVB is like 5%, and UVC mostly gets filtered in through our ozone. Not much of that really gets in here, but that's going to be a different wavelength too. So that's going to be measured in nanometers, and nanometers are very, 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 very small. Not something you'd be able to measure with a ruler. All right, so UVA is really what people talk about when they worry about the damage of UV lights. And so a big worry is going to be something like skin cancer. And the reason that's such a big worry is because sunlight, when it gets in that high energy, it can actually mess up your DNA and it can mess up your cells. So basically, without making this too complicated, what it's going to do, it's going to change those things, and it is going to basically make your DNA so it's not coding right. So I know we've talked about DNA in a couple other videos, so I'm not going to get too much into it, but remember, DNA works kind of like a code. It's not that it is a code, it's that talking about it like code makes it make a little more sense. All right, and so it's basically going to damage your DNA. It's going to make it so that it doesn't work right, and that's what can cause cancer. Cancer is basically your cells stop working right, and then they can just multiply and multiply and multiply without anything holding them in check. So the UVA is usually kind of indirect DNA damage. UVB, though, can cause direct damage to your DNA. It changes your DNA. It can be dangerous. All right, so that is the big reason why there is sunscreen. So like my bottle here, sunscreens try to stop this from happening. Now, before I talk about how sunscreens stop that from happening, there's something that is an even more powerful force that stops DNA from getting damaged too much by the sun, and that is your skin itself. So here is the big secret. I need some water. Here's the big secret of skin color. That is pretty much the reason why people have different colors of skin, is because they are from different areas, and those different areas have different amounts of sun. So people originated in the continent of Africa, specifically the northern eastern part, and that is where they call it the cradle of civilization, and that's an area that's really, really sunny. So a lot of the whole continent of Africa, not all of it, but a lot of it, especially in that northern part, it's going to be really sunny there. And so when I talk about some of the dangers of the sun, so the sun is something that's also really important. You can get vitamins like vitamin D from the sun, but also if you get too much sun, then it can damage your skin. It can cause you to get skin cancer. So when you look at people from especially like the northern Africa, they're going to have a lot darker skin than somebody like me, and I'll get to why my skin looks the way it does too. So they live in an area where and them and all their ancestors live in that area, and they get a lot of sun. So their skin is darker, because people with darker skin, it actually protects you from getting too much sun. Okay, so you might be wondering, well, if there's a danger of getting too much sun, then why doesn't everybody, and especially because that's where we all originated from. So everybody, if you trace back your ancestry long enough, you're gonna get back to Africa. Everybody came from Africa. It's just how long ago your ancestors decided to move to a different place. And so whether it's I believe one of the longest groups that split off from there went to Australia, but then there were other groups that went into Eurasia, and eventually some of those Eurasian people made it all the way over to America, and that was a long way. So I'm talking about the Native Americans, and it wasn't until much, much, much later that the Europeans made it to the Americas. But anyway, so you might be thinking, well, if the sun can hurt you, and we all come from that area of Africa, and those people have darker skin to protect them from the sun, why doesn't everybody? Well, take a look at me. So I'll use myself as this next example. So as people move north, I'm one of those people who their ancestors moved out of the continent of Africa, and they moved into northern and western Europe. Now, northwestern Europe, if you've never been there, is very, very cloudy. So as opposed to northern Africa, where it's really sunny, where my ancestors were from, it was really, really cloudy. So they didn't need all of that. It's called melanin. That's the pigment that basically causes your skin to be darker or lighter. The more melanin you have, the darker your skin is. So my ancestors have, and myself included, have less of that because we lived in a really cloudy area. So we actually needed to get more of the sun that was coming through. It's really cloudy and really rainy. If you've ever been to England, it's very cloudy, very rainy. And so you see most of the people who live there, and definitely the people who didn't come there recently, that's what they look like. So you do need some sun, you just don't want to get too much. All right, so, and that's why you see all throughout the world, you can see the people who are from really sunny areas tend to have darker skin. The people from really cloudy areas tend to have lighter colored skin. So that is really just the big secret of why people have different skin colors. It's actually really interesting when you get into looking at it. So that's the natural way that you are protected against the sun. Now, if you are like me, whose ancestors were from the Northwest, most of my ancestors, some difference, but a lot of mine are from places like England or Ireland or Scotland, where it's very cloudy, very dark. So they needed to get more sun. But now I live, and I'm guessing most of you live in Iowa, and Iowa is much sunnier. So if you notice the people who are historically from Iowa, the Native Americans, you can look up like the Iowa people or the Sac and Fox, you'll notice that their skin is a lot darker because there's a lot more sun in Iowa. So when we come here, our skin pigment is actually not a very good match for living in this kind of environment. But we are humans and we can always come up with other solutions. So first of all, the really easy solution, clothes. If you wear clothes like this, it's going to block too much sun from getting into you. And then you'll notice that even me, I tend to wear short sleeves, and I've got not quite as much as I will in the summer probably, but you can see here's the pigmentation on my arm versus my upper arm. It's a lot lighter up here, so you can see that my shirt sleeve is blocking some of the sunlight there. Oh, believe me, I'll get more of a difference, and I know a lot of the people watching this probably will too. All right, so that's one way, is clothes block it, and that's why wearing a hat is going to block things like that too. So what about sunscreen then? All right, so that's another way. If you've got part of your skin, the easiest way is to just wear clothes. So like you could wear long sleeves and that would cover up this whole thing, but you can also put on some sunscreen. So what does sunscreen actually do? So it's going to block it from the sun from doing that. So just like clothes they're a physical block. That's nothing chemical about your clothes. It's just going to stop that light from getting in because they're going to hit clothes and be absorbed or bounced off the clothes instead of on your skin. The sun is going to either bounce off or get absorbed into there. Oh, that's the big reason why melanin. It's going to bounce more of that light off and less of it will be absorbed if you have more melanin. All right, so let's talk. All right, so there's UVA, UVB, and UVC, and there is UVA and UVB blockers. So UVC isn't nearly as much of a concern, so people just don't really worry about that as much because it gets caught in our ozone in the atmosphere. But UVA and UVB are the ones that can do us harm. So that's what sunscreen works against. So it's going to either be a physical barrier. Most old sunscreens, that's exactly what they were. They were made with lots of different metals, and they just stopped things from even hitting you at all. Now, a lot of sunscreens like this one are going to contain a lot of chemicals that are more of a chemical block. So like zinc and titanium oxide are the ones that historically have been in sunscreens a lot, and they bounce those off. So those are inorganic chemicals, but there's also organic chemicals in here too that block this. So I'm not going to make this too complicated, but basically what you need to know is there are things that are a physical barrier. So think about it like just setting up a wall, stopping something from getting through. And then there's also chemical barriers that are basically the things that are going to chemically stop something from getting in. All right, so since I'm talking about sunscreen, I do need to make a quick note about the safety of sunscreen. So there are some chemicals in sunscreen that we've recently found out could be dangerous. There's not a whole lot of research on that. So I just want to put a note in, do your own research on this. You're going to find out that a lot of them are what's called, I don't know whether you're supposed to pronounce it as GRACE or not, but GRASE, generally recognized as safe. And I think that's what it is. Generally recognized as safe is what the FDA does something if there's not really a whole lot of testing on it. So it's important to know that in our FDA, something to go to market doesn't have to be proven safe to be able to be sold. Instead, it needs to be proven unsafe to be taken off of market. So do your own research. I'll let you make your own decisions on that. But there are some things that people have raised concerns on, including some things that might be linked to skin cancer, ironically and sadly enough. So do your own research on that. All right, so if you want to see firsthand what the effects of the sun are, I would say there is an easy way to do that. So get a piece of construction paper, pick a pretty bright color. And there's a couple things you can do for this. If you want to do it real simple, just put it straight up with one side facing outside of a window and leave it there for a couple days. And then what you can do is then fold over the sides and notice the difference. So that's one thing I've got here. So I don't know if you'll be able to see this very well on here, but this side is the side that was facing away from the window, and this side is the side that was facing the window, and this side is faded. So if you've ever noticed that paper that you put up in the window, it fades in color, that's actually the sun damage doing its work. And I notice that every time we put up posters for the events at the library, because when I take them down, I notice that if we line them with construction paper, the side that's facing away from the window looks like it did when we put it up, and the side that's facing the window has faded. And you can even see, like right here, there was a window blind that was in the way here, and so this side ended up not getting faded. So I also tried a different thing with this. So you can see I've got written yes and no, so I could tell the difference. But on the yes side, I covered my hand with this sunscreen and then plopped it on there to see what would happen with the sunscreen part. Now, it didn't work out quite how I expected. I was expecting the sunscreen to get more absorbed into the paper and kind of go away, but it's probably difficult for you to see, but you can see the handprint right there. And ironically enough, it just looks kind of whitish because there's still the layer of film on there. So I can't quite tell how much it is, but if I scrape it away, it looks like it did protect at least a little bit against it. So that, in summary, is really what these sunscreens are for. They're for stopping the sun from getting to you. Now, I would still say if you're actually worried about the sun, then it is important to create what barriers you can for the sun. So especially if you're like me and you have not a lot of melanin in your skin, then things like hats, things like clothes in the summer are going to be really useful to you. Now, if you do have more melanin in your skin, it doesn't necessarily mean that you don't need to protect your skin at all from the sun. You definitely do. It just means you have a little bit more protection than the people who don't. And by the way, if you are wondering, there are extremes on both ends of a lot of melanin and not very much melanin. So you might have heard of somebody having albinism or being albino, and that actually means that your body isn't producing melanin. And so if you notice somebody who has that, the only thing that's different about them is that their body's not making melanin. So you'll notice that their skin is very, very pale looking. It doesn't mean there's anything really wrong with them. It just means that they don't have that melanin. And yes, that does mean that those people are especially sensitive to the sun. Somebody with albinism, most people that I've known who've got that, they're going to wear more protection against the sun because it can really give them a bad sunburn. So that's what a sunburn is damage from the sun. And so it's basically the sun damaging your skin. Now, you might also notice that somebody with albinism, that their eyes look different. And that's because your skin that you think of isn't the only place where your melanin is. It's also going to be in your hair and it's going to be in your eyes. So that's going to change the color of that as well. You'll notice I have a decent amount of melanin in my hair and in my eyes. I have very dark brown eyes and I have very dark brown hair. So I have quite a bit of melanin in those areas. Not nearly as much as somebody who has black hair, but I'd say my eyes are about as much melanin as you can get. If anyone has ever noticed, it's actually difficult to see my pupils. That's how dark brown my eyes are. But somebody with blonde hair has far less melanin in their hair. And same thing with somebody with blue or green, like my wife's eyes. She's going to have less melanin in her eyes. All right, so we've got albinism basically means you don't have any melanin in your body, or at least very little. So is there an opposite of that? That's a great question. And the answer is yes, but not that we've seen in people. So you might have noticed somebody who has very dark skin and they have they have very dark looking skin, so they have a lot of melanin, but they are not what we would call melanistic. So melanism is the opposite of albinism, and it's not something we've ever seen in people. So even though there's people with very dark skin and a lot of melanin, they don't have what is an overproduction of melanin. But there are animals that do. And if you've ever taken the time to Google animals with albinism, like an albino alligator or a snake or ferret or whatever, there's lots of different things, pretty much most animals you can think of. There are also the opposite. There are a lot of animals with melanism. So if you were to type in a melanistic snake, that's a really cool one, and you'll find a picture of a snake that is jet black. It is a solid black color, and that is because that snake's skin, it's producing tons and tons of melanin. And so anything with melanism, it's going to basically create a huge barrier against the sun getting in. And you do find that in a lot of animals. And as far as I know, so far we have not found a person who has melanism. They would be a very interesting, I'd say very striking looking person. But all right, so that's just a little bit about the sun, a little bit about sunscreen. What the sun does to help us. Remember, it gives us vitamins. And also the sun is definitely not going to be considered a bad thing because also it helps all of the food that we eat. It depends on the sun. If you eat plants, the plants directly use the sun to, well, I'd hope you eat plants, but when you eat plants, the sun is going to directly make those grow. And even if you're eating meat, that animal that you're eating, it ate the plants. So everything depends on the sun, but too much of a good thing can definitely hurt you. So it's important to realize that there's a balance in there. And that's something you'll see a lot in nature. You need a certain amount of something, but not too much. Like how I talked last week, maybe a couple weeks ago, the one where I made cake. How a lot of nutrients, you need a certain amount of them, but too much of those can be unhealthy then. So this is kind of like the same thing. You can get not enough or you can get too much sun. All right, so thank you everyone so much for joining me. I know this is a lot more talking, a lot less direct experimentation than we normally do, but I figured this would be a neat one to talk about. So thank you everyone so much for joining me. My name is Zach. This is Hudson Public Library, and this has been Science Explosion. Bye.